Hi, good morning or good afternoon or good evening, depending on the time zone where you are right now. Welcome to the second day of container training. So today we are going to first review the exercise, like the hands-on labs that I gave you yesterday to see how we can write Docker files for a microservices application. And then we will continue with networking. We will see how to expose containers, how to connect containers together. We will see how to set up a local development workflow. We will talk about the container network model. So we will see what is that exactly, what does that mean, how to do service discovery, and we will talk about a tool called Compose. But first, let's write some Docker files. So we didn't get many questions yesterday in the chat, so I don't know if that means that everyone was able to write the Docker files easily, or if quite the contrary, maybe everybody tried and after writing from Ubuntu was like, what's next? So let's see how to write these Docker files. And I want to make this useful for everyone. So if you haven't had the opportunity to write Docker files, or if you tried but fell on, had some issues or whatever, I'm going to show you how we can do it. And even if you did it, I'm also going to show you some little tips, tricks, not exactly optimizations yet, because remember what I was telling yesterday, premature optimization is the root of all evil. Before optimizing, we should make sure that things work correctly. So we're going to first do it right, and then we will do it better, so to speak. There is also saying in French which says le mieux est l'ennemi du bien, which translates roughly to better is the enemy of good, which means that sometimes we try to do things better, but it's better to do things right, to do something good that works, and then try to do something better. It's a problem that some of us can have, and I'm going to put myself in that bag. Sometimes we try to do something, we have a specific target, we have a specific goal, and we start optimizing, we start trying to do things better, even though the basic stuff doesn't work. And I think, if I could time travel and have a good conversation with me of 20 years ago when I was learning computer science and starting to write my first kind of real programs, etc. That's maybe one thing that I would try to teach myself. First, get it right, bug-free, something that works, and then we can try to add all the bells and whistles and features, etc. But it's completely useless to add all the bells and whistles if your program is completely buggy and crashes all the time. So let's do this. So we need to work on this repository here. So I'm going to first reconnect even to my VM. Where is it? Boom, boom, boom. Container training, lab environments. I'm here, Jerome Petazzoni, that's me. So I'm going to select that, copy paste. Password is still training. All right, here we are. This is the Wordsmith repo. So that's where I have the application that I want to Dockerize, like to containerize. And I'm going to start with, let's say, web. All right, let's look at the instructions. Where did I put them? Here. Okay. Web. So the web server is written in Go. To compile Go code, we have two options. Here they tell us, well, if you want, you can use the Golang official image, so from Golang, or you can use any base image you like. Maybe I'm a fan of Debian or Arch Linux or Gentoo or Fedora or whatever. In that case, I could use that distro and I could install the Go compiler in there and do that instead. Which raises an interesting question. Is it better to use an official image or to make my own? Is it better to use that Golang image as suggested here, or is it better to, from Ubuntu, apt-get update, apt-get install Golang, etc.? Well, generally speaking, it's going to be better to use the official image, because some folks, went through all the effort and sometimes the pain of making an official image, and very often they kind of put a lot of extra effort to handle some specific corner cases of containers. We're going to see a very good example of that when we containerize the database, for instance. So generally, it's better to use the official image when there is one. However, sometimes you want to do something, a little bit different. Maybe you want a special version of Go or Java or whatever, or maybe you want, for some reason, maybe you want an image that has both, let's say, Python and Node, and you're like, should I get the Python image and add Node, or should I get the Node image and add Python, or should I get like the Debian or Ubuntu or CentOS image and add both? Well, in that particular scenario, my personal preference would be to go to the last option. Instead of saying, hey, let's get Python and add Node, or the other way around, no, let's get an image with, let's say, Ubuntu and add both Python and Node. However, the even better option in that case is to kind of take a step back and look exactly, why do I need both in that image? And very often there's going to be a better option. Just small example, but for instance, when you do web development, maybe you have a web server using Flask or Django or FastAPI, and at some point you are compiling some CSS or transpiling TypeScript to JavaScript or whatever, and so you think, oh, I need to put Python and Node in that image. Well, we will see tomorrow when we talk about image optimization, multi-stage, etc., that we can actually, in that case, we would use a multi-stage build where we would have one stage with Python, another stage with Node, and we would combine both so that in the final image we have just what we need. So all that to say that very often, not all the times, but very often, when we feel like we're doing something that's not super clean, that's not like super neat, like for instance, oh, I'm going to put Python and Node in the same image, very often in that case, there's going to be a cleaner, a better way to do it. And that's part of the little tips and tricks that I'm going to teach you this week. All right, back to our web server. So they say we could use the official Golang image, so let's do that. And you know what? I'm going to actually copy these instructions and put them in my Docker file here, and just like comment them out or something, That way I have them right in front of me and I don't have to go back and forth between the Docker file and the instructions all the time. Okay. So this is a web server written in Go. We can use the Golang official image. Well, let's do that from Golang. The entire code is in a single source file and should be compiled like this. Okay, go build dispatcher.go. So I'm going to do run in front of that. Now, of course, before compiling the code, I need to copy the code to the container, right? So I'm going to do copy dot. This creates an executable named dispatcher, which should be launched like this. Okay, I'm going to do cmd./dispatcher. Listening on port 80, that's going to be the output of that command. And well, let's see if that works. Like, that's a very basic Docker file. Use a base image, copy the code, build the code, and then we indicate what to run in the container. All right, so docker build -t web, and we see what happens. All right. Okay, now docker run web, listening on port 80. Yeah, that's what it's supposed to show us. Yeah, listening on port 80. So far, so good. Is this really working? At this point, we don't quite know yet. You know, like it says that it's listening on port 80. It says that the server is up, but maybe, you know, when we connect, maybe it won't quite work well. But that's what we wanted to see so far. So, all right, let's go to the next one. Except, I don't know if many of you went that far, but there is actually a little problem here. If I try to stop the container, see, I do Control-C and it doesn't stop the container. What's going on here? The technical explanation behind this is it's a little bit tricky. So if you're not familiar with Unix and signals, etc., don't worry, don't panic. But I still want to explain like what's happening here. Okay, when I do Control-C, normally, if I'm running a normal classic Unix program, for instance, if I run top shows me the top processes on the system, so the processes that use up the most resources. And so if I do Control-C, it stops it. And it's a kind of common convention. And when you are on a Unix system, if you do Control-C, it stops the program. So when I'm doing Docker run something, there is this kind of expectation. If I do Control-C, it's going to stop the program. And that's what we saw yesterday. Maybe you remember when I did Docker run jpetazzo/clock, it runs this container, and when I do Control-C, it stops the program. Now, it seems nice and simple, but if we look into the details, now things are going to be not as simple, because when I do Docker run, I'm actually running a container. So I have my container, which is running, but I also have the Docker CLI. What I have is, it's a little bit like a remote control, so to speak, or if you will, a little bit like a keyboard and screen connected to the container. And when I do Control-C, then there is a pretty good question. What should we stop? Should we stop the container, or should we stop the keyboard and screen? And I'm going to give you a little parallel with what happens when you go to a data center. And I don't know if many of you have ever been to a data center, but imagine like a little bit like a huge warehouse with a bunch of cabinets, like with servers in them. And these servers are typically rack mounted. So imagine like a big pizza box, but very heavy, and you stack them. You typically, like, you can put about like 40 servers like this stacked on top of each other. And since you have like thousands and thousands of servers in these data centers, and so you don't have keyboards and screens there, because it would be a huge waste of everything, of resources, space, energy, etc. So you have all these servers, no keyboard, no screen, and most often times you just control them remotely with a tool like SSH. But sometimes you need to actually plug a keyboard and screen because maybe the network is down, or like maybe you need to do the initial installation, or maybe the machine is in a really bad state. So long story short, you cannot connect to it through the network, and you need to connect an actual keyboard and screen onto the machine and see what's going on. So what we do is that you typically have a little cart with a keyboard and screen, and you push the card to the machine and you plug it. Okay, what's the connection between this little story, this example, and containers? Well, with containers, it's kind of the same idea. You have a bunch of containers running on the machine, and they don't have keyboard and screen. They're just running. And sometimes when you need to see what's going on in the container, that's when you're going to plug a keyboard and screen and see what's going on in the container. So now when I do Control C, that's the equivalent, if you will, of like pulling the, imagine I unplug the electrical cable from the machine. So now the question when I do Control C, do I want to unplug the container, the machine, or the keyboard and screen? It's a good question. And generally, what we want is to stop the container. So how is this going to work? Well, and that's where things get a little bit tricky. When you do Control C, the normal behavior, if Docker weren't doing anything special, then if I do Control C, it's going to stop what we call the foreground process. So the process running in my terminal here. So when I do Control C, it's going to stop not the container, but the Docker CLI, the remote control, the keyboard and screen for my container. So if Docker were not doing anything special, Control C would just leave the container running and bring me back to my command line shell. So Docker is doing something special because typically that's not what we want. If I do Control C, usually I want to stop the container. So what the Docker CLI does is that when I do Control C, it's going to conceptually propagate forward, proxy that Control C thing to the container. Technically, it's going to detect that I did Control C, and it's going to send a signal to the container. Now, if we want to be more accurate, you can't send a signal to a container. That doesn't make any sense. You can only send a signal to a process. So it's going to send a signal to the first process in the container. Okay, so what? Well, let's have a look at the processes in that container. So I'm going to do Docker PS. Okay, that's my container. And now I'm going to do Docker top D85. So that's the first characters of the container ID. And this is going to show me the processes running in that container. And I might need to unzoom a little bit. Okay. So I have two processes in this container, and things can be a little bit confusing when we look at them that way. But what's interesting is that you can see we have dispatcher. So that's the program that we run in the container. But you can see that I have another process, bin-sh-c dispatcher. That bin-sh-c might ring a bell. Remember yesterday when we were doing like the Docker history, we saw that we had bin-sh-c everywhere because we need to parse the command line, and Docker outsources the parsing of the command line to the shell, and that's why we have bin-sh-c everywhere. Okay, interesting. Now, another thing that I want to do, because this view of the processes in the container is, I think, not super clear, so I'm going to try and make it a little bit better for us. I'm going to do Docker exec D85 PS FAUX. Okay, what's that? What did I just do here? I used Docker exec. Docker exec is a way to run a command inside a container, inside an existing container. You have a container and you want to check something, whatever you want, like you could check existing files with ls, or running processes with ps or top, or grab something in a log file. You can do Docker exec. The same way that when you need something on a server, you can SSH on that server, connect there and see what's going on. You can use Docker exec in a container. All right. So what I can see here is that in my container, I have dispatcher, which is PID 8, so process number 8, and I have binsh-c dispatcher, which is PID 1. Or to phrase things differently, the first process in my container is binsh-c dispatcher, and that process then starts that other process. Okay, so what? Well, when I said earlier, well, you cannot send a signal to a container, you can only send a signal to a process in a container. And when we say, oh, I'm sending a signal to the container, what that really means is I'm sending a signal to the first process in the container. Okay, so if I put all this information together, that means that when I do Control-C, I end up sending a signal to the first process, to PID1 in that container, that's binsh-c dispatcher. So I send a signal to that shell program here. Okay, and what's wrong with that? Well, that's going to be another little tricky thing. In a normal scenario, when you send that signal to a process, it stops the process. Except the default behavior for the shell in that particular situation, when it receives that signal, is to ignore the signal. I'm not going to dive into all the little details because if you're just learning about Unix signals this week, that might be a lot of information. So I don't want to overwhelm everyone. But the default behavior in that case is to just ignore that signal. That signal is the thing that kind of asks nicely to the process, please shut down. So so basically, let's put everything together. When I do Control-C, the Docker CLI detects that I did Control-C, and it's like, I guess you want to stop the container. So it's going to send that signal, which means, hey, can you please stop that process? It's sending that to this shell, but the shell just ignores it. So I can do Control-C as many times as I want. It's not going to do anything because the shell ignores it. Okay, so how do we fix this? First, how do we get out of that container? And then how do we make it so that when I do Control-C, it actually stops? Well, so first we're going to stop that container, and I'm just going to do docker kill d85. So there we go. That stopped the container. Great. And now what I'm going to do is that I'm going to use the JSON syntax. So remember, with angle brackets, double quotes, build again, run again. And now if I do Control-C, ta-da, it works, it stops the container. So why does it work this time? Like, what's the difference? Well, I'm going to run the container. Now I'm going to do, let's see, what's the container ID? E449. Okay, docker exec E449 ps faux. And you can see the difference. You can see that, so that was before PID number 1 was the shell and dispatcher was PID number 8. After, so once I use the JSON syntax, PID number 1 is dispatcher. Because when I use the JSON syntax with the angle brackets, that means, hey, Docker, you don't need to invoke the shell to start that program. You can run that program directly because I'm giving you the exact command line, the exact parameters that you need to be running. So dispatcher ends up being PID1. Now, why is it stopping correctly when I do Control-C? Because, and again here, like a small simplification, but because the default behavior for a Go program when I do Control-C is to stop in that particular scenario. So generally speaking, it's a good idea to be in that scenario, so to have my program, my code be PID1, it's better than the other scenario, which is to have the shell being PID1. Now, just put in a corner of your memory somewhere that it's not always a complete solution. The reason why this works is because the Go runtime sets up a custom signal handler for that particular signal. If you don't know what signal handlers are, you can safely ignore that last sentence. But if you know, you know, as we say. Okay, so that was a kind of we went kind of off track because again, I wanted to bring something to everyone here. If you're just getting started with Docker, I wanted to show you how we write that Docker file. And if you have a little bit more experience, then I wanted to bring up this conversation about signals. But again, if that whole thing about signals felt confusing and weird and what is this about, don't worry too much about it. It's fine. It's not mandatory to move forward. All right, can I show the Docker file? Yes, absolutely. So we have this, and I'm going to, let's see, maybe like this, and I'm going to paste it to the channel just in case. There we go. All right. Okay, so we built our first image. That's great. Now we can move to the next one, words. So again, I create a Docker file. And it says, Words is a REST API backend written in Java, blah, blah, blah. Okay, so I'm going to get all that, put that in the Docker file, and let's do this. On the Debian or Ubuntu distribution, we can install Java and Maven like this. So remember what I said, like what, 10 or 15 minutes ago? I said, oh, it's better to use official images, except in that case, the instructions do not tell us which official image to use. Instead, they tell us, hey, we can install Maven and the JDK like this. So I'm going to just follow these instructions. That's so let's say from Ubuntu, run apt-get update, and then run apt-get install, all that. To build the program, we can invoke Maven like this. Well, first we need to copy the source code, so copy ... Then run Maven verify. The result is a file named words.jar located in the target directory, blah, 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 and we can run it like this. Okay, I'm going to put cmd, java, etc., and let's see what happens if we do that. So I'm going to docker build -t words. So first problem that we already had yesterday. When I do this, it says, hey, you want to install Maven and Java, basically. To do that, I also need to install these 200 million packages as well. Do you want to do that? And I'm supposed to press enter to continue. But remember what we said yesterday. We're not here to press enter to continue. The build process needs to be fully non-interactive, completely automated. So what I'm going to do is I'm going to, we did that yesterday, remember? We added -y here to tell apt-get, if you have any questions, assume that the answer is yes, so that it continues without asking for confirmation. All right. Now I do my Docker build. And this is going to take a moment, which is going to give me a little bit of time to answer questions. So there is a question about how are we going to make the web server accessible on the host, and we're going to see that a little bit later today. Like at this point, I'm just building the images. I'm not even checking if they actually work, but we're going to talk about networking within like half an hour, something like that. And then we will see how to expose these ports. Yes. So why didn't we mention the name of the file that we are copying? Right. So here, what I did is a copy ... and so we have, I personally have two strategies when I build Docker files and I need to copy files in the container. There is either the copy ... which is like take everything and put that in the container and then you figure it out. This is great when you have a bunch of files and things are often kind of changing, evolving, etc. So you don't want to manually list all the files and you don't want to edit the Docker file each time you have new files. So you're like, okay, copy ... and that way I have everything. So that's strategy number one. The problem of that strategy is when you are on a big, let's say, messy repo, you have hundreds or thousands of files and subdirectories, and it's a complete mess. And so sometimes in that case, it's better to manually, handpick the exact files, directories, etc. that you want. I'm not saying that one strategy is better or worse than the other. It really depends on the circumstances. Personally, I prefer to do copy ... but we have to put that in context. That's because very often I work on very small repos, small services that are very much self-contained. And so in that case, copy ... is often the easiest way. But if you are working on bigger projects, bigger repos, you might have to go the other route and handpick the parts that you need, and that's totally fine. Excellent question. If we Docker run -ti web, we can use Control-C. So is it better to use the -ti option when using Docker run? Okay, this is a really good one. And let's see. This is such an interesting question that we could almost make a conference talk about this. The small subtle effects on like very unexpected options. So I'm going to try to give you the lightning talk explanation rather than the half an hour conference talk version. This is because when you do Docker run -ti, then the process in the container will have a controlling terminal. Like what? So little demo. So I'm going to go back to Wordsmith Web. And I'm going to do Docker run web. Okay. And then Docker run -ti web. Good. And now I'm going to do Docker PS. Okay, so I have both of them. Great. Now I'm going to do Docker exec 0914 PS. Okay. And Docker exec C913 PS. Okay, almost. Oh, sorry. Let's do PS FAUX. There you go, and PS FAUX. Okay, and now we play the games of the, well, in French we call that le jeu des 7 erreurs, the game of the 7 differences. When you have two very similar pictures but with small differences, like and you need to find these differences. So first thing we can see is that the PID here is different. Okay. Other difference, that's all the same, that's all the same. Here, PID1. The VSZ is a little bit different, but that's not very important. You know, it's not relevant here. The RSS is a tiny little bit different, but also not relevant. Now, this is interesting. See, here we have TTY. In that case, we have question mark. In the other, we have PTS/0. What's a TTY? So TTY stands for teletype, and in Unix, a TTY is a terminal, and these days it's more often like a pseudo terminal than a real terminal. Terminals, like the idea comes back all the way from the time when computers were huge, like machines, like huge mainframes. You could not have a computer on your desk because they were, you know, the size of like 10 fridges, and they would be in a basement or whatever. So what you would have on your desk would be a terminal. And the first terminals were actually like a typewriter. But when you type, it's going to send the characters to the computer, and when the computer sends things back to you, it's going to print them on the paper. And then after that, we moved to what we call like glass teletypes. So like it's basically a keyboard and screen, but without the computer part. So imagine keyboard and screen, and then there is a cable that goes to the computer. And so early Unix systems had this notion of a terminal, and that was a pretty important thing. You know, you could have like a computer, and you would have maybe a few dozens or maybe a few hundreds of terminals, and everybody was connected to the same computer. So that concept of terminal kind of stayed and stuck around, and there was a bunch of concepts associated with that, like the concept of foreground process. You know, what's the program that is currently running on the terminal? And when I do Control-C, what technically happens is that we stop the process in the foreground. Because you might have a bunch of programs running in your terminal. So when I do Control-C, I don't want to stop all of them. I just want to stop the one that is in the foreground. Okay, so how does that tie with our container story? Well, if I just do docker run web, I'm in this scenario here, and by default, I don't have a terminal, I don't have a TTY, and then Docker uses the behavior that I was telling you about like 15 minutes ago. You know, I do Control-C, Docker is going to send the signal to PID1. Okay. Now, if I do have a terminal, if I use docker run -ti or -it, same thing, then I have a terminal. That's the whole point of the -t. So you can see here TTY PTS0. That's just the string to identify that terminal. So now the behavior is a little bit different. When I do Control-C, what Docker does is that it's going to send a signal to the foreground process. Okay, so what? Well, let's see. Now I'm going to switch back to the non-JSON syntax. Docker build -t web, docker run web, and so 1DEB, okay. Docker exec 1DEB PSFAUX. Okay, and then one more to see. Sorry, I should have started with it. Docker run -ti. -ti web. It's 5f5. Okay, so Docker exec 5f5 PSFAUX. All right. So now you can see that dispatcher and bnsh-c dispatcher are on the terminal. And if I remember well, that might be the L here that indicates the one that is in the foreground. I'm not 100% sure about that. But basically what happens if I do docker run -ti, when I hit Control-C, it's going to send the signal to that dispatcher process, even if it's not PID1. So does that mean that we should use docker run -ti all the time? Not quite. My personal preference would be to fix the issue, so either with the JSON syntax or something else. It's interesting that if we do docker run -ti, then we can use Control-C, but that's typically not how we will solve that issue in that case. All right. Other questions? Video issue. Okay, so on my end, the video encoder tells me that everything is fine. Is it lying, or let me know if anyone else has a connection issue, and I'm going to. Oh, actually, we might have had a short network interruption. Is anyone else having issues, or? Okay. All right. Okay, so next question. So did I answer that one? Yes, I did. I did answer that one, so we're good. For Java AppWords in production, shall we get the jar file compiled and start from OpenJDK directly? So there is a pretty good question here that very often Java developers ask me, which is, and I don't know if it's exactly the question you're asking, but it's a very common question, which is, should I compile my jar file locally and then put it in the container, or should I build it in the container? And it's tempting to build locally and then just put the jar file in the container, but this is unfortunately not what we should do. Ideally, we should run the whole build process in the container. Why? Well, because if once we want to build with a CI/CD pipeline or something like that, we're not going to commit our jar file to our Git repo and push it to Git. We're only going to commit and push our code, and then it's going to be our build pipeline that will take care of building the jar file. So ideally, we need the entire build process to happen in the container. And okay, then video issues were good. Okay, I hope that we won't have other video problems. So back to my Java thing. Okay, let me stop all these containers here, right? Docker kill, docker ps-q, there we go, up. Stop all the containers. And okay, so we just built our Java application. Now let's see if it works. Spoilers, it won't work because I deliberately made a couple of mistakes in that Docker file. Docker run words, unable to access jar file words.jar. So I'm like, that's weird. So how do I troubleshoot something like this? Well, personally, what I like to do is just get a shell in the container. So I'm going to do docker run -ti, the image, bash. So now I have a shell in the container and I can check what's going on. Well, first, things are a little bit messy here. Again, you know, like I'm mixing up my application code and also my system file. So I'm like, no. Let's get out of here and let's start by putting like workdir/app, for instance. Let's let's go to a different directory so that things are a little bit nicer and cleaner. Okay. One thing that we will notice when working on that app is that the build process is pretty slow because each time we do a Docker build, Maven is going to re-download all our dependencies. And this is not specific to Java. We're going to see that problem with other languages, other frameworks. And that's one thing that we will want to optimize. I will show you how a little bit later. For now, I'm going to endure the 20 seconds build time, but we will see how to optimize that in a moment. Okay, let's try again. Docker run. Okay, good. So now I have all this in a separate directory. I can see a little bit better what's going on. And indeed, I don't have words.jar. What's going on? Well, I go to my Docker file, and it says, oh, the result is a file named words.jar located in the target directory. That's the kind of stuff that happens when we don't read instructions or documentation in full. So, okay, that means that I need to run that command in the target directory. Okay, that seems to work. So now let's change the Docker file. Let's get out of here, edit the Docker file, and here I'm going to add workdir target. So let's move to the target directory. Now I do a Docker build again. Now I have to wait 20 seconds again for Maven to do the whole build, and I'm like, I really want this to get better, but how? Okay, almost there. And now Docker run words. Server started. Yay, it works. Okay, now we do Control-C. Oh, it doesn't work. Well, guess what? This is exactly the same issue as what we had before with the Go program. So first things first, I'm going to Docker kill that container. And then I'm going to use the JSON syntax here. So something like cmd java-xmx8m. Wow, that's going to be long and complicated. Is there a better way than using the JSON syntax here? Yes. The trick is to put exec java, etc., etc., etc. What is this exec command, like this exec thing? This is a shell built-in. This is a shell function which is going to tell to the shell to kind of replace itself with the Java program. So again, that's like if I want to go to all the little details, it's going to be a little bit complicated. But why it's called exec? Because at first I'm thinking, well, exec just means execute. So what does that mean here? Well, in Unix systems, when you want to run another program, there is what we call a system call, and that system call is called exec. Okay, in reality, it's like exec VE, I think, and then you have functions called exec VP, exec LE, etc. But at the core of it, it's like exec, and exec does something a little bit weird, especially if you're not familiar with Unix systems. It replaces the current program with another. So this is something, if you've done some systems programming or whatever, you might have heard about fork exec. If you have not, I'm going to give you a little comparison with biology, which may or may not help depending on what you know about biology. But in in the human body, and not just the human body, but most like living species, when you want to create a new cell, you don't just have a cell that creates a new cell like this. No, each cell divides with that process called, is it meiosis or mitosis? Well, one of these. So you have one cell and it goes through this whole process with DNA duplication, etc., etc. And at the end, poof, you have two cells. Yay! So now, what do you do if when you need like a new muscle cell or a new bone cell or whatever? Well, you have and I don't know how to say that in English, unfortunately, but you have, undifferentiated cells or pluripotential cells, a cell that has potentially can become another cell. So that cell kind of clones itself and then becomes another cell. Well, it's exactly what we do in Unix systems when you want to run a new program. You start with one program. That program is going to duplicate itself using something called fork. It's called fork because it's like, imagine a fork in the road. So you start with one process and you fork, and then you have two processes. And one of these processes is going to replace itself with that exec function. The exec function is like, imagine, transform yourself into that new program. So that's why we have exec here. That means replace yourself with that new program, and the end result is that the Java, the JVM, is going to be PID1. Okay, well, let's try this out. Build, and we have once again to endure a 20 seconds build by Maven while it downloads half of the internet. And once it's done, any second now. Okay, Docker run words, server started, Control C, it stops. Yay, great. So now I would like to optimize, this 20 seconds runtime here because it's annoying. But first, good question. When should we not use CMD exec? Is there a good reason to not use CMD exec? Well, there are some scenarios where you don't have a shell in the image. We're going to see that tomorrow when we talk about image optimization. So in that case, you can't use CMD exec. Generally speaking, it's generally a good idea to use exec or the JSON syntax. On the top of my mind, I cannot think of a scenario where that would be bad. So you can always use the JSON syntax or put exec, if you have lots of parameters and it's annoying to put the JSON syntax everywhere. And that's fine. But there are also scenarios where it's not really bringing anything to use exec of the JSON syntax. So that's why in some images we just don't care. We're like, why not? But yeah, it doesn't hurt to use exec or to put the JSON syntax. All right, now how can we make that build a little bit faster? Because here it's 20 seconds, but it's also a very small program. So if it were a bigger program, this could take minutes and minutes and minutes. And I remember, so when I was working at Docker, one of the things I was doing very often is meet like companies and engineering teams using Docker and listen to the problems that they had. And there was this startup where they were like, yeah, man, we tried Docker, but honestly, that was garbage because the builds were super slow, etc. And so the CTO was like, yeah, that this is bad. We decided to stop Docker because of this problem. And the engineers were like super sad because like, well, we really like it and we feel like there has to be a solution because we can't imagine that everyone would have to wait like 40 minutes each time they have to rebuild something. And yes, there is a solution. So, it's the It's the kind of day where you're super happy about your work because you can show a nice solution to people, and then they're like, "Yay, we can keep using Docker. We're happy." So what's the solution? Well, let's look at the Docker file again. Why is it slow? Let's try to remember how the caching system works. We go through each line of the Docker file, and each time Docker checks, did I already do that before? And if yes, it can use the cache. But if anything changes, then Docker cannot use the cache. So, okay, that didn't change. And here we do copy ... And when we do copy ... if you change any file, then this is going to bust the cache. This is going to ignore the cache. So if I change anything, even if I create, let's say I create a README file, copy ... will have changed, and Docker will re-execute everything after this point. So what's the solution? The solution is to think about, okay, what takes 20 seconds in that case, or 45 minutes in the case of the company I was telling you about. What takes a lot of time is installing all the dependencies. So can we install the dependencies before copying all the code? Yes, we can. So in this specific scenario, we have to know Java and Maven a little bit. And what we need to know is that the dependencies are defined in that POM XML file. Honestly, I don't know Maven, so I would be completely unable to explain to you how that works, but this is the equivalent of a make file or something to describe how I build, etc., etc. But this is the file that Maven uses to know about the dependencies. Okay, what do I do with this information? Well, I'm going to copy that file first. So copy pom xml dot, and now I'm going to run maven verify. Verify. So this is going to install the dependencies. Great. Now I'm going to copy everything else, and I'm going to run maven verify again. Okay, let's see what happens when we do that. Docker build. So this is the first Maven verify, where Maven installs all the dependencies, and so that's the long and expensive part. Like that takes like 20 seconds or something like that. All right. Now we copy the rest of the code and we run Maven verify again. But see, now instead of downloading and installing everything, it's just checking that we have everything. So it's like, hey, I need what? I need this. Yep, we got it. I need that. Yes, I got it as well. I need that thing. Yes, we got it too. So it only takes 5 seconds to check all that instead of 20 seconds. And now if I make some changes, like if I create a README file, whoops, no, I didn't want to encrypt. I just wanted to save and quit. Sorry. We got this. Okay, now if I build again, you can see that it did skip the first Maven verify. Because if I look at the Docker file, so this has not changed, this has not changed, this has not changed, so we can still use the cache. This has not changed, so I use the cache. This did not change, I can use the cache. And it's only when we hit that line that it says, hey, now we have a change, and so now we need to rerun Maven verify. So this is an example with Java, but during the rest of the week, I'm going to show you examples with other languages and frameworks. There's going to be an example with Ruby, another one with Python, and it's always the same idea. When you have a build that is really long and slow, we try to identify, okay, what is taking a lot of time here, and can we put that in a separate operation before the other operations. You could imagine in a way like the build process like a little bit like imagine like a pyramid where you have the lower layers that are bigger and slower to build, and the higher you go in the pyramid, like the smaller and faster to build the things are. And you want, like all the expensive stuff, installing dependencies, etc. You want that to be in the lower layer so that they don't change, because as soon as one layer changes, everything above needs to be rebuilt as well. All right. So I think I answered that one. When should we use the CMD exec? Is this similar to the concept of golden images? Not exactly. I mean, the general idea, like the container images are very similar to golden images. So first, to just explain, like to everyone else, like what's this concept of golden images? This is an expression that we often find with virtual machines, where you kind of have two strategies. If you want to deploy your stuff to the cloud, strategy number one, I create a VM, like maybe like Ubuntu, Debian, Fedora, etc., and then I use config management and scripts, etc., to install and configure all my stuff. Strategy number two, I create an image, a VM image with everything pre-installed and pre-configured. So now when I need to spin up a new server, I'm just like create a server with that image, and boom, I have everything ready to go. Well, that's kind of what we're doing with Docker files. A Docker file is a way to define a container image, and conceptually, container images are very similar to the golden images that we work with typically in cloud deployments, or like at least VM-based deployments. Yes. How does Docker know that there is no change in POM XML? I think it does a full comparison. Let's see. So okay, first I can try touch. So this will not change the content of the file. Actually, wait. First, let's do a Docker build. Okay, Docker build is fast, great. And you know what? Instead of doing a change in POM XML, in that case, I'm going to do it on I'm going to do it on POM XML so that I answer the exact question. So I'm going to use touch. Touch, it doesn't change the file, but it's going to update the modification time of the file. So now if I do a Docker build, no change. Okay, so changing the date of the file doesn't, it doesn't do anything for Docker. It's like, well, it's still the same file. So I guess that it means that Docker is going to compare that file. And to be honest with you, I don't know if it's doing a checksum and a hash, something like that, or if it's doing a full comparison. But it figures it out. But at least we know that it's not just the timestamp of the file. All right. Does the copy ... line bust the cache because of the Docker file itself? Otherwise, nothing changes in the multiple builds. Yes, if I do a copy ... then when I change the Docker file, yes, it's going to bust the cache as well. And so here, we might want, if we wanted, we could optimize even further, either by copying just the source files, or by ignoring the Docker file and the files that we don't need. Or in that case, personally, I think like, no, I'm cool with that. A 5 seconds build, yes, I can do even better. But remember, like that thing I was saying, like le mieux est l'ennemi du bien. Sometimes trying to do better is not. It's I'm sure there is an equivalent idiom in English, but I can't find it right now. But that says that it's better to have something that works rather than trying to do something even better. I'm like, okay, a 5 seconds build, good enough for me. Yes, I could have a 1 second build instead of 5 seconds, but if it means that I need to add 3-4 lines in my Docker file, etc., is it really worth the trade-off? It's completely up to you. You might want to decide, yes, I want to add 3 lines in my Docker file because I want my build to be even faster. And that's absolutely fine as well. Then when we're back, we're going to do the last of the 3 containers, which is the database. And then we will move on to networking.